Okay, GIT in 100 minutes, 100-ish minutes. Okay. So what is version control? Manages documents. It's basically documents, no images, etc. It's only for documents and to note changes in documents and to manage it. It's also known as revision control. The history of Git. So if you guys are familiar with Linux, Linus Torvalds used another software, and at some point he wanted to give it up. So he started developing a new version control system, and he specified 3 points. So first, the visibility, to see who committed the changes, and etc. Patching should be very easy, take not more than 3 seconds. If you guys are familiar with other types of version control, it's a very long process to make patches. And then strong safeguards against file corruption. So Git, the Git meaning, foolish, okay. Okay, so if you guys know this guy, everything makes sense. So types of version control systems. So the early version control systems is centralized systems. So for example, you have let's say 6 users using the system. Everyone commits to one master. And this one master, maybe a remote server, etc. And then everyone, in order to commit, has to be connected to the central server. Meaning that it's not offline, it has to be online for every commit. Example, SVN, I think, works that way. Decentralized. So this is actually the slogan of Git. Everything is local. So there is remote servers to commit, but everything starts with your own computer. So you start to commit code to your own computer, your own local system, and then if you want, you can push to a remote server when you are online. So it's very good. So if you're on a plane for 8 hours, you can still write code without internet connection. So how to use it? It's very simple. It starts with 3 basic steps. Create some files, make changes, add it to staging, and commit it. So staging is you specify for Git which files you want to be included in a certain commit, and then you commit it, it bundles up, and you have a message to explain your changes, and this is all about a commit. A commit. A commit starts with the root commit. So you start the project, you make the first commit, probably the first files in the project, and then later on you make another commit, the second commit, and everything is sorted by time. So the first commit, then comes the second commit, the third commit, and you can see in the line and the timing. Every commit depends on the other commit. Okay, so commit hashes. So every commit is generate a hash containing the contents of the commit. Later on, maybe if we have time, we'll go in and more deep into how object works in Git, and how Git blobs and Git tree blobs works. But every commit, it takes the message of the commit, the file structure, everything together. It makes a special hash to it. So this is a explanation, like if there is a possibility of a crash of 2 commits having the same 2 different commits having the same hash. So it's basically 99.9999. So, okay. Counter-adjustable storage. This is very interesting thing in Git. So because there is a guarantee that every commit with a certain hash is different, that means that the system can guarantee if they see a Git object in their Git database. So let's explain a little bit before. You make a commit to any file. Git saves the commit in some storage, so it saves the changes in as Git storage. And the key of the file has a hash. So the name of the commit is actually the hash. So later on, if you want to use a commit or whatever it is, Git looks for the certain hash and retrieves the value of that file. And Git has a guarantee that if you need this specific hash, this is the commit you're looking for. And it's even more than Bitbucket and GitHub are reusing hashes even for other projects. So for example, you have a project that has jQuery inside. And you have another project from a different location, let's say in China, that someone using a project also uses jQuery. And both using the same file. So Bitbucket has the same blob with a hash number once created by one project. They will reuse the same object for another project. So it's very convenient for them because they don't have to have such big file systems to have everything. And also it's very, very fast because if you can see, if you're on GitHub and you fork a repository, the fork takes a second. And the repository can be gigs of gigs because they're reusing all the objects.
How does it know that I want the same jQuery that's very somewhere else?
So if the jQuery file contains the same content, the hash will be exactly the same.
So it matches the hash.
Exactly. So the key is the hash. And I can show it actually in code, and to see the same hash will be generated. So let's see. So I have a folder over here. I'm going. What? Yeah. So I'm going to create start with Git, just the start process of Git. So Git works with mainly in command line, but there's a lot of GUIs to use for convenience. Also, there's a lot of IDEs comes Git integration as default. So, but it's very good to know command line because later on you'll have to use it anyway. So let's start. So I will start with the empty folder. There's a folder called test. I will initialize Git. So the first thing is Git starts with the Git command. So if I type in Git, it will show me all the information about Git. So Git works, it starts with the Git command, and then the type of command you want to run. So it's kind of like the noun. And for example, Git actually, for certain types, Git will have like a sub command, and certain types they will have the command right on Git. So I will start with Git init. Git init is the first command you run in any folder you want to initialize a new Git repository. So you type in Git and init and initialize the new empty repository. I'm going to show you the folder, and you will see a new hidden folder git.git. So everything Git tracks is inside this folder. So you can see everything inside this folder. If you will go into this folder right now, it's going to be, there will be certain folders, but the objects will be empty because nothing was committed yet. So the Git storage is empty right now. So I will start creating some files. And let's type in here. Okay, hello world, and save it. I will type in git status. This is a command that tells you where are you. So is the files changed? Is the files committed? Whatever, everything about Git will tell you with the git status command. Okay. Okay. DS store is a Mac thing of tracking certain settings of the folder, so just ignore that. Okay. Let's see. I don't see my file. Okay. Okay. I see. For some reason. Oh, okay. It's not saved yet. Okay. Okay. Oops. Oh, that's not good. Oh, that's odd. Oh, okay, I got it. Okay. Okay. Okay, so you can see there's an untracked file test.txt. And untracked files means that Git never actually saved the file to begin with. It's not like you had a previous saved file, a committed one that you made changes. It means that it's a new file and it's untracked by Git. So the next step you do is you type in git add, the name of the file. And before that, I'm going to show you something in the folders. So over here, it's empty. And the second I press in git add txt, let's see, it's not the right folder. Yeah, it is. Okay, but let me show you objects. Oh, okay, I see it. Okay, so 9.5 will have a folder, and this is the contents of that file. So Git zips the file and creates a hash with the contents of the file. So this is the file, and also you can see is the folder contains 9.5, and this is actually the prefix of the hash. So the actual hash is 9.5 D0, 9, whatever. So they split it up in multiple folders for easy searching for the system. So the next thing is you commit your file. So git commit. Yeah, specify a message and commit. So one file change, and there will be a new object inside. Okay, there's a new object. There are going to be two new objects. First is a commit object containing the information about the commit, for example, the author of the file, the timing, and the message. And the next object is a tree object. A tree object is specifying how the folders look like. So there will be just one file. So there will be folder test has one file, test, and then the name of the file, and then the value of the hash where to locate if you're looking for the file. Okay. The next thing is I'm going to talk about remotes. So you probably want to push your code to some remote server. So I'm going to use Bitbucket for that example. Bitbucket is probably best for private use because they have free and private repositories, and GitHub for some reason don't. So so I'm going to create a new repository. Okay. So I'm going to let's say call it as you can call it everything. Let's call it YIDLUG. Okay. Okay. So Bitbucket will give me a URL. So this is the URL to locate Bitbucket's repository. So I'm going to connect my local Git to use the push code to Bitbucket. So I'm going to go into my folder. Okay, I'm typing git remote add the name of the server. So by default, Git will call the remote origin, but you can call it whatever you want. You can have multiple remotes too. So let's use origin for now. Origin, and then the location where the origin is. So paste in, and that's all. It's connected to the remote. So let's push the remote. git push origin master, and we're going to so currently we have one commit in our system that's not pushed to the remote. We create some changes to files, we commit it, and we have one commit in our system that's only on our system and it's not on Bitbucket. So we're going to push this single commit to a remote server. So the remote server is called
Why do you have to type an origin master? If you create a remote, why do you have to type origin
Okay. Okay. So the Git has a thing by default that if you were in a certain branch, we're not yet to branches, but I guess we'll explain later why it's best to use to specify the branches, and I will tell you a story that actually someone didn't do that and he messed up big time. So we'll explain it later on. Okay. So git push origin master. So the default branch in every Git repository is master. So there's no branch in the remote because nothing was committed yet, but the default is master. So we're going to git push origin master, and it's going to push every commit on the current branch to update the remote branch origin master. Okay, it asks me for my key. Okay, this is from authentication. Okay, oops, I have to add permissions to the repository. So there's two ways we can authenticate with the remote server. There's HTTPS authentication with specifying the username and password. Git has a thing that it can cache your username and password, but the best way is to do it with SSH. So the way you do it is you create a key, a public key, and then you go to your Bitbucket account and you add a public key to Bitbucket, telling you that every request for commits from this public key, they shall accept. So
FBI allows that?
okay, so the first thing we're going to create a key. So SSH keygen, and that will generate a key for me, and the key will be in a hidden folder. I'm going to spit it out on the screen. Okay, this is the key. Okay. Okay. Yep, got it. Okay. Okay. So just paste in the key and you're good to go. Okay, let's try to push it again. Okay, it's done. So they created a new branch on the remote repository because it was a new repository. There was no branches there yet. Sure. So let's go to Bitbucket. YIDLUG source. And here it is. Hello world. Okay. Let's show something. Okay. Let's go into the 1 second. It 1 second. Okay. Okay. 95. Okay. Okay. I'm going to create just a dummy file over here just to save the content. Okay. And then starts with 95. So this is the hash that was generated for Hello World. I'm going to show you is that I'm going to create a new repository in a different folder, and the same hash number is going to be generated because my file is going to be Hello World. And okay, so let's see. Okay. So okay, so creating a new folder called test2, going to the, okay, initialize another Git repo, create another file, I even can create a different file, a file name. Doesn't matter, because if the contents are the same, Git will reuse the same contents. So the file name is stored in 3 objects. So 3 objects is a mapping of how the tree and files look like. So if you rename, for example, if you just rename a file, Git will only change the tree object because the content stays the same. They will just have a new mapping that this file maps the same object you had before.
File object for
No, there's only one change in the three blobs. I'm sorry, in the 3 objects. So 3 objects will be changed because there's new mappings to new name of files. But the contents of the file stays the same, so everything stays the same. So I'm going to call it, let's say, test2.txt. I see, okay, we'll have to move it. It's accidentally saved to the wrong place. So, test. Okay, so there's a new file. Git status shows me there's a new untracked file, and we're going to add. Okay, let's first look at the objects and see what's going to happen. So this is in the old folder. Let's go to. So this is test2. Okay, objects. Okay. Git add. Okay, so here it is 9.5, and this is the number, and I actually saved it over here. You can see at the 9.5, everything stays the same. So Git reuses the same content. And even more, I'm going to add the remote in the same remote repository, and I'm going to try to push changes. And you will see that only one object is going to be actually 2 objects are going to be pushed. One for the new commit message and new timing because it's different from the other commit, and the second is the tree object because it's a different file name. So git origin. Let's go to copy the URL. Oops. Oh, okay, forgot the add. Okay. Git commit. Okay. Oops. No. Okay, there's a merge config. I see. Okay. Oh yeah. Okay. So we'll go on later on into the thing called merge hell, and we'll explain it a little bit more. So Git. Okay. So the first thing is for every push into a remote server, the first thing you have to do is you have to be in the same page with the remote server. You can't just push commits without having the commits from the remote server. So the first thing is you pull the changes from the remote server.
Did you make a new one now? Is the same?
No, so I'm going to reuse the same thing, and I'm going. Yes, and you will see that there's going to be pushed only 2 objects because the contents of the file stays the same. So they will reuse the objects that already committed from the other file. So the first thing is git remote. Git pull origin master, so it will pull all the changes. Okay, let's see. So they have the test.txt and the test2.txt, and now we can push origin master. Okay. So, okay, 4 objects. So the 4 object is because I had a merge conflict. So the merge conflict had two objects, one for the commit and two for the tree. The tree object, the old commit had one commit for the message and also one object for the tree. But instead of having to use the 5th objects for the actual content, they reuse the same thing. So, let's see, only total 4 objects was sent. Okay, and then let's go back over here. Let's see, and here you go. You have the same, all of the files over here. Okay. So this is basically Git. You add stuff, and then you commit stuff, and then you push it to your remote. And then if someone makes changes to the remote, you have to pull from the remote to have the updated version from the remote, and then you can commit your changes.
So based on the explanation, if you go back to the previous screen, we have test and test 2. What I'm seeing now is just the tree, right? This is just the tree.
Yes, so
it's not the file.
So over here is the file.
That's the same by both.
Yes. And Git, yeah. Yes, you see the hash, actually, the same hash. So, and if there is a hello world in Bitbucket and some other planet, they will reuse the same thing. So, it's even more. Bitbucket. So, even more. Bitbucket says that if you have some private information that you deleted from your repository and you want to destroy it, you have to call them Bitbucket or send them an email to actually remove that from their storage, because even if you deleted your repository, the object still stays in their system.
Why?
For caching purposes, I guess. I don't know.
It has nothing to do with Git.
Well, but yeah, so Bitbucket for their convenience, they want to save as many objects as possible.
Forever?
Yes, so it stays forever. Okay. Okay. So, oops. Okay, divs and delta. So let's start with a simple file. You create some stuff to a file. Hello world, one line. Div creates div calls it. You added a new line, so there's a plus. Let's actually show it in command line. Then we'll get back to the slides. So. Okay, so I'm going to add a new line. Okay, save it. And never mind. Okay, for some reason, okay, no new line at the end of the file. Okay, that's the reason. Okay, so I created a new line, so they think that's actually the new line is of the old line. So they create 2 adds. So you can see that I removed the old one, I added a new hello world with the new line, and then a new line with something else. Okay. There's no Git for every Git divs works on lines. So that's the problem. If you have there's some common best practices in programming. Don't have a line longer than a certain amount of characters, and also don't have, let's say, a file more than 40 lines. It's not just good for programming, it's actually good for Git, because Git will create a new object for every change in a file. So even if you change one space in a file, a new object with the exact same contents will be created. So you will generate a lot of disk space if you have very long files. And the same is with divs. So if you have a very long line in a file, and you make any change in the file, Git will generate a remove for the file and a new add with the new lines. Bitbucket is actually smart enough to show you on the line where you made the changes, but I don't think it's from Git itself. Maybe some other Git div tools will show you it as well, but.
Div color word with the red express.
Oh, okay. So over here is remove the line, added a new line, and then added two new lines. So back to the slide. So the same over here. So you created a hello world. You add another line. There's another plus, and then you made a change. So there's a remove, and then there's an add. So branching. So one of the coolest things about Git is branching. Branching is super easy, but also a lot, it can be confusing. So branches. You start with initial commit, master. The master is the default in every Git repo. You start with initial commit. You make another commit, and at some point you decide, let's say you work with another team member, and the other team member wants to make changes. He wants to start with the same code you started with. So he wants to start, let's say, from the second commit, but he wants to diverge. So he wants to start making other changes that's not going to be in your files. So he branches out. He gives it a name, let's say project A, and you can commit on new changes on your master branch. The new changes will not be reflected on the branch project A, and they will commit new changes on the project A, and it's not going to be on the master. Everything is going to be separately, and on and on. Okay, merge. So at some point, when you branch out from a branch, at some point you want to merge in, and you started working, let's say, on a certain project. You have a master branch that's the production machine sits on the master branch, and you want to start with a new experimental code. So you branch out, and at some point later on, you're satisfied with your code. You want to merge it back in to the master branch. So there's a lot of merge strategies. So there's fast forward, recursive, octopus, there's ORs, and subtree. We're going to cover a few of them. So fast forward. Fast forward is the simplest way of merge. So fast forward, the way fast forward happens is, so let's say you started with the initial commit, you make a second commit, you branch out to project A, you made some commits, but in the meantime, master wasn't updated. So master stays the same, and the only places where new commits was added was on the new project. So the simplest way to make a merge is fast forward. So you fast forward the master. So the master is left behind with two commits. There's no commits on the new branch, and you just fast forward the master. So look over here. You just fast forward it. Show it again. There's a new two branches, the two commits on the branch, and there isn't any new commits on the master branch. You just create it as one, and you just fast forward the branch.
Fast forward.
What?
Why did they call it fast forward?
Because you fast forward. It's left behind, and you fast forward it.
Not worried about any changes, just fast forward to the latest one.
Yeah, you fast forward it to the latest one. So fast forward with.
If you have time, that get the head when you come to this.
Okay, let's we're going together. Okay. Okay. What?
He wants to know what the command is to fast forward.
So fast forward, Git will try by default to make a fast forward commit if they will fall back on a recursive strategy. Okay, so let's show let's go into the command line. We'll create some new branches, and then we'll merge it in. So I'm currently in this branch, test2, and we're going to create some new files for a new project. So currently, if you type in git branch, it will tell you the star means you are in the master. There's no new there isn't any branches besides master. So let's say we're going to work on a new branch, a very cool project called YIDLUG. So we're going to branch out. So git branch, give it a name. So YIDLUG. Okay, branch is created, but you have to check out in the branch. So you have to be in the branch. You just what?
Branch again. Let's see.
Okay, it will tell you that you are still a master, but there is a new branch YIDLUG. Okay, so let's get to the branch. So git checkout and check out YIDLUG. switch to branch YIDLUG. But nothing was added, nothing was changed. Okay, so let's create some new file. So, yeah, okay. 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 If you press in git status, it will tell you there is a new on-track file, project.txt. We'll add it. Okay. Git status will tell you that there's a new file, project.txt, that's in staging. And next thing you have to do is commit it. So staging means that you put everything in the box and then you have to label the box. So it's just the staging means that this all of the files in staging will be set as one commit. So the next thing is commit. Okay, give it a message. Project commit. Okay, the thing is to look at is master, but there wasn't any change in master. So the only change was in the new branch YIDLUG. So YIDLUG has a new project, a new file called project.txt, but master wasn't changed by any chance in the meantime. So for example, we're going to go back to master, and
with your file system when you branch out?
what?
What happens in the file system when you branch
So Git will change the file system accordingly to the branches you are into. Yeah, so Git will set up your file structure. So you can see I switch back to master, and there's only test and test2, and master there's no project.txt. And if I go back, git checkout YIDLUG.
Where did that file go? The project.txt, where did it go?
So Git added it to Git storage mechanism, and when you go back, you check out again. Git will set up your file structure with a new how the files should look like in this branch. But the bits and pieces how Git does things, everything is saved in the .git folder. So it's saved as objects. So it's zipped and with hashes and stuff. So right now, ls and there's project.txt because you checked out to YIDLUG branch. Okay, so now at some point we want to merge the project.txt should be in the master branch. So let's get back to the master branch. So git checkout master and git merge YIDLUG. Okay, fast forward. Why it's fast forward is very simple, because there wasn't any committed added to the master branch, so a fast forward was possible. So let's go back to the slide. So the next thing is recursive three-way merges. So recursive three-way merges is when, let's see, you start with the master branch, you create a commit, you branch out, you make a commit to the new branch, you make a commit and the master in the same time, you make a new commit to the project, and you want to merge it in. So then it starts to happen to be a conflict, because there was changes in the master in the same time. There was changes in the branch in the other branch in the same time. So Git has to figure out how to merge it. So Git creates a special commit. It's called a three-way merge. It creates a special commit, and it tries to find out the differences, how everything should look like. And this commit will be the how Git resolve the merge conflict. We'll go into a little deeper. So a thing to know about Git and Git commits is that every commit has a parent. The way why parents has to be in Git is that you want to know changes. You have to know let's say you started with a file with 10 lines, and you made some changes, and in the div in the changes says that line 5 was removed and line 5 was added different content. But it depends. So if the parent commit was different, you can have the same instructions at different files, remove line 5 and add something to line 5, but depends on what the previous commit was, the look, how the files will look differently. A better example is...
the whole file stored as an object? The new file, once you made the changes, you get an object for the whole file. So why do you have to know the parent? You have the whole file.
No, but this is just for the divs in Git, to know a div. So you...
Just to show the divs, not
What? No, it's not just this because okay, but it has to do also when you create a Git div. Git wants to know exactly what the changes is. Okay, well, we'll go into parents a little later on because. Okay. Okay, we're going to get to more in deep into parents where it's actually very, very important for Git how to figure out how merge conflicts should be resolved.
If you don't mind, when you answer a question, just repeat the question so we hear it.
Okay, no problem. So the next merge strategy is octopus. Octopus means that if you have multiple branches merging in at the same time, so it's kind of like an octopus with a lot of feet. Okay. Conflict. So let's start with a simple file. There's a branch foo. There's a branch bar. There's branch foo has test and one line, bar the other line. Then there's branch bar, foo and bar, and buzz. So merge in bar into foo. So what shall Git do? Is buzz a new line, or maybe buzz was removed in foo? Is test a new line, a new thing in foo, or it was removed in bar? There's a lot of scenarios that can be happened. So the way Git figures out is to look a little bit back. So you start with the files, and Git looks a little bit back, and they'll see is that you branched out from foo bar. So you started with foo bar. So it means that buzz was actually a new line, and test was replaced. Foo was replaced by test. And Git knows how to resolve it. So Git will resolve it as test bar and buzz. Okay. Yeah. So over here is the parent. Why parents are so important. So common ancestors. So what is exactly ancestor? It's an object, idea, style, occurrence. Okay.
Does there always merge into the master branch? How does it work when you merge?
You can merge in any branch in any branch. What?
Branch that you're in. How does it?
So you go into a branch and you merge in a separate other branch into the existing branch.
You have to specify your branches?
Yes. So you merge in something. So for example, if you want to do the opposite, merge in master into another branch, go into the other branch and then merge master.
Show an example of how to merge.
So it's the same thing. Okay, let's okay. Let's edit for Q&A. Yeah. Okay. So ancestors. So the ancestors is the very important thing of resolving conflicts. So an ancestor, in short, a base where others inherit. So a common ancestor is in Git is the latest commit both branches have in common. So for example, branch A and branch B. Right away, you can see the common ancestor for this branch is the latest commit, because this latest commit is when all the two branches are on the same page and they have the same contents. But later on, as things get changed and there's another merge into master, you will see there's a new latest common ancestor, and this is the latest common ancestor. Because we are not caring about the old stuff, we're caring about the latest commit where both commits were the same as master. So later on, we only care about these three commits, because this three commits was the new changes applied at the latest time these two branches had in common. Okay, so What?
Merge based on some infrastructure.
So I think merge base is actually the same thing. Yeah. Yeah. So.
Is the point of the merge that not keep not without open or no?
Yeah, because they don't care. They just want to know one thing: the latest time where both branches had the same contents, and to see how things diverge.
The actual commit
How do you still have a branch B if you merge the branches?
So and Git, what? The merge commit is the diamond shaped commit.
Oh, so that has to be, okay.
Okay.
The circle should be a little lower.
Okay. Well, if I understand it, that's the point.
You
Okay.
branched out again after that?
So in Git, when you create a branch, branches are now deleted when you merge in. All the branches stay alive till you delete it. You can delete branches, but everything stays. You have to manually delete branches. I'll show you an example. Let's say we actually merged in YIDLUG into master, so we don't care about YIDLUG anymore. We're going to delete it. But actually before then, let's explain what exactly is a branch in Git. So a branch in Git is only a few bytes in size, because the only thing branches it's a pointer to a certain commit. Every commit is saved differently, and it's saved as a object with hashes. And then the branches is basically a pointer that points to a certain commit. So this branch starts from this commit, and everything above is a part of this branch. I'm going to show you actually in the files. I'm going to show you in the files. So over here, projects, Git. Let's see a second. Okay. So over here is branches. So branches. Let's see. Fs. Okay. Okay. So you can see. Okay. So there is heads, and there is two heads. There's head. Head is the master, and then there's head is there's master, and there is YIDLUG. So I'm going to open it with a text edit. Okay. This is very small. Let's open it with something else. Sublime. Okay, so it's basically it points to a commit hash, and okay, so this is the commit hash YIDLUG is pointed to. So let's go into GitLog. So you can see. Okay, so FDF40, and you can see. Let's see. Okay, so over here, FDF40, so it points to this commit. So it's basically just a pointer. So you can delete branches, but branches is very just a few bytes. That's it. You can leave it. Okay.
SVN, every branch is like a full copy.
Yeah. So this is the objects are shared across the whole Git system. You can even share, as I told you, with Bulkit. So you can share objects with a lot of repositories too. Okay, the next thing is Git workflow with Git. So workflow with Git, there's a lot of options, and every option has this certain sweet spot where this certain type of workflow works best. So the development branch is I think the most common. So development branches works it's very, very simple. You start with commits in a dev branch, you make some commits, at some point you branch out, and you push all the changes to, you branch out and you push to a test branch. And the test branch test it and then push it into production. In the meantime, you make some new changes to the dev branch. What?
You push the production from test?
Yes. So after testing, that's it for manual testing. So the way it works is, let's say the developers make changes, let's say for 2 days, and at the end of the second day, you branch out, and all the new changes is going to be new changes on the dev branch. But test has all the changes from the last 2 days, and the test team can test it for as long as they want, and new changes will not reflect the test branch because it's a separate branch. And as they're comfortable with the code, they can push it to production. And production has the same code as test. And the same thing happens again. So it has like kind of cycles of development, let's say every week, and you push, and the same thing happens again, and you push the test, and then to production. This is a very simple workflow. There's a lot of pitfalls with this. Okay, we'll have to go into later on. Maintainable version branches. Maintainable version branches are very good for a company that maintains, for example, hardware. So, for example, they want to have actually a copy of certain versions, so they work in versions and version numbers. Usually, a company like an internet company, there's no such thing as versioning because they make changes and it automatically updates the whole system. It's a website.
Move fast and break things.
Yeah, kind of. But there's no customers that has a certain version and other customers have a different version because it's one cloud system and everything has the same version. So maintainable version branches are very good for hardware or companies that have customers that are relying on certain versions and it has to be maintained. So, for example, emergency patches, security patches for versions. So it works is you start with some commits, you branch out as a version, and you start using the version. Then you branch out to another, you make some commits on the other version, and then you branch out. Once you branch out, the latest commit from the old branch is actually the release of the version number. And if, for example, if you have like emergencies, you can push it up over here and put some more commits for patches for this version. So version 1 has a security update. You can just patch it, and it will not reflect other versions because every patch is especially customized for the certain version number. And again and again. And you have 4 versions, and over here it's not branched out yet, so it's still in development. So the moment you branch out, it means it's a finished branch, and the branch is ready for production. User branch. User branch is basically is very common for a team with very just like a few people working in the team. So it's very simple. Everyone has a branch, make some changes, and then everyone pushes to master. So you can see John committed changes first to master, and you can see over here there's the commit, the merge commit. He pushed it to master, and then because of Bob come in a little bit later, you first have to pull everything from master because master will reject your commits because you don't have the latest from John. So the first thing is you pull from master. Once you pulled in everything, you can commit yours. Fork. Fork is very common in open source communities. So the way fork works is let's say you're looking for a certain third-party software and you find it on GitHub. And you're uncomfortable with some of the code, but most of the code is okay. You want to make some changes to the code. So the way you work is, the first thing you fork the repository to your username, so it clones the full repository to your username, so you have ownership of the full repository, and the changes will only reflect your username, so the open source project will not be reflected. You can create pull requests. We'll get into later on. The open source project shall take your changes, but if not, you made your changes. You have everything from the repository from the open source community, and then you make your changes. It's kind of like branches, but a little bit more because it's not a branch, it's actually a full repository.
Why do you need a separate repository? Why can't we just do it in a separate branch?
So the open source community has to give you permission to create a branch. If this open source project don't want to get you any permissions to create branches, you just fork the whole thing at the username. So the basic way is to just fork it on GitHub. GitHub has a fork button, takes a second. Fork, and it's in your ownership. Takes a second.
It creates a branch in the
No, so it creates a full copy on your end because it's a clone. They call it a fork. What? Because they added a lot of features because they know the from where you cloned it from, there's a lot of options. So you can see if there's changes from your parent and try to pull in new changes, or you can commit changes.
How can I have a repository that I got from somewhere else and make GitHub believe that I forked it from somewhere?
Oh, okay. Probably you changed the origin, the remote origin. No, you can actually do it. You can the way actually forks works is they set automatically the origin, the remote server to the parent server. So if you add your remote service to point to someone else, it would probably work the same way.
How do you add remotes to the remote?
It's not adding a remote to the remote. You add a remote to your project. Point.
You add the remote to your
No,
remote clone of your fork.
basically,
GitHub doesn't know about that.
Okay, yeah. So yeah, it's a challenging thing. So adding a remote in GitHub itself.
Clone, difference between clone.
Yeah. Okay.
Difference between clone and fork is clone is locally to your account. Fork is actually.
So there's actually so first of all, fork is not a Git thing. Fork comes from GitHub. GitHub, it's actually a clone, but GitHub added some new, a lot of features because they know from where you come from. So they added some metadata to make it easier to work with it. So that's a fork. So you have, like say, the main repository, and you fork out, and then you fork out again, and you fork out again. So there is the very big project, Linux project. And the way Linux project works is it's very interesting. So the Linus Torvalds is the main project owner of the repository. So he knows, let's say, 5 guys that he can trust on certain types, certain sections of the program. So they all of this 5 users forked the repository from him, and then let's say there's a guy that works on drivers, so he has a fork from Linux, and the fork is all about drivers. And then he trusts 10 developers to work on drivers, and it's a fork of the whole project. And then he trusts 10 developers, and the 10 developers forks the project too, and he commits to him, and he commits back. It's kind of like a bureaucracy in a company.
Local branching.
But it's very useful because in such a huge project, you can't have control on everyone that does commits to the system. So it goes of a hierarchy of trust. So the main project owner trusts 10 people, the 10 people trust another 10, and a 10, whatever it is. So if you want to make changes to Linux, you have to know some guy. That guy knows some guy, and the way it works the way up to the master. So this is how fork works. Feature branch. A feature branch is a latest buzz, and there's a lot of people are switching to feature branches. There's even tools that started implementing feature branches in their system. So feature branch. Yeah. So Jira is one of the guys that started work. Yeah. So Jira and Atlassian has Bamboo build system. They all enter.
Atlassian has Jira.
Yeah, so they added a lot of things for Feature Bench. So Feature Bench has challenges, but Feature Bench is very cool. So the way Feature Bench works is, you started with your main project, and let's say you want to create a header for the project. And there's a website, you have to create a header. So what you do is, you just branch out a new branch, and you call it header. There could be a lot of people working on the same thing, but everyone has to commit to this certain branch. And one of the big things of a feature branches is that it's not touching the project, and you can test the header separately from the production website. And if you are satisfied how the header looks, you just push it into master, and there's a new header inside master. And the same thing, you start a footer, and you make some changes, happy, back into master. The problem with feature branches is, if you have feature branches, the feature branch should not last longer than a day or 2. The problem with that is, if there is feature branches more than a day or 2, the merge hell comes into play, because there's going to be branches that will not have the same code for a very long period of time. And then a month, let's say you have a big project going on for a month, every project for itself can pull in code from master to have all the latest change from master, but these two projects will not have code shared together. So there's a lot of code going to be committed at once. And there's going to be a lot of overrides and conflicts.
How are feature branches different than regular branches? Why do you need special tooling for it?
So feature branch, no, it's just a workflow how you do stuff. So you use the same branches.
It's not like Jira has special support for feature branches.
Okay, so in Jira, if you, it's not just even feature branches. If you put in the comment or the name of the branch has the name of the ticket in Jira, Jira will recognize it in the ticket. So you go into the ticket, they will show you all the branches for the ticket or commits.
GitHub also?
Yeah.
Jira also recognizes
Branch name and the commit message.
Commit message closes pound whatever, it automatically closes that issue.
Okay.
In GitHub. In GitHub,
So and even more, it works with pull requests. So okay. Let me show you before we're going on a little bit later about how pull request works in Bitbucket. I think it's called a merge request. Gitbucket calls it a pull request. Whatever, it's basically the same thing. So.
How do you create a pull request on the command line?
Oh, there is. I don't think there is a way. There's a way. Yeah. You have to probably download some tool. What? Okay. Okay. So you ask about if there is a way in the command line to create a pull request. I don't think so.
it has nothing to do with Git.
It has nothing to do with Git. True. It has nothing to do with Git. So I'm going to show you in Bitbucket how a pull request looks. And we will create, let's say, I'm going into the feature branch workflow. I'm going to create a header and then open my pull request. So in test 2, we're going to create a new branch. So git branch and call it header. And we branched out. Now let's go check out to the header branch. Oops. Okay, so we switch to the header branch. Now let's make some changes for the header. Okay. So let's see. Let's see. Okay. Okay. Okay, so we created a new header, so we're going to add it, header.html, then we're going to commit it, commit, header. Okay, so it still sits on this branch. We're going to push it to the remote, but the remote doesn't only has one branch, so we're going to force the remote to create a new branch. So the way we're going to do it is git origin, git remote, git push, whoops, what is it? Git push origin and then header. And okay, so you can see no branch, and it okay, and it actually tells you remote create pull request for header, and it tells you the link where to create a new pull request. So for the question before, creating a pull request to command line, it's not possible, but Bitbucket will help you out to create one. So let's actually go to this link. Let's go to Bitbucket and see. So it created a new branch in Bitbucket, and let's see. And there it is, header, and you can see header.html, and okay. So so you have to so when you have to give push permissions. Git branch with a name. No, so you push to the branch name. And if there is an existing, yeah, so if there is existing branch, just the new commits will be added. If there isn't, it will be created one. So over here we see there we have a master and we have header, and there's even labeled main branch. So we're going to create a pull request. So over here, create pull request. So we give it a title there. We'll put in some defaults, and let's say we're going to create a pull request. So create pull request.
When somebody doesn't have permission to push, he needs to do
No, you can. So the idea of a pull request is about workflow. So instead of merging, you do the merges. You create a pull request for someone to review, and it's very nice because when you go now to a pull request, you will see there's a pull request pending and with a title. And if you go into the pull,
you don't trust somebody to push.
it's not like about trust. It's used for a lot of It's code review is a very basic example. So there's a team. There's a lot of developers making changes, and the company has a policy that whatever in the company has to review your code. Or if it's a senior developer or whatever it is, you create a pull request, someone looks at the code and looks, you made a error over here, let's fix it, push it again, and then we'll accept your pull request. And you can even comment. So
you oppose it afterwards?
And on the pull request, there's an option to merge. So even more, the Bitbucket and GitHub added a lot of things. So you can even comment on the line of code. So you can comment. And you can comment on a line of code. You can comment on the pull request in general. So there's what is that commit? So you can see all the commits that this pull request is going to bring with. Activity is about comments. Overview is the author, and then you can watch it. You can get email notifications of incoming pull requests, and there's all the other types of build systems that can react to build requests. So if you open a build request, a pull request, a build system can test your code and see if the code passes, and it even comment on your pull request. And I've seen in some build system, if the test fails, it will put in like angry emojis in the comments. So there's a lot of cool stuff with pull requests. So let's merge it. So you can decline it, approve it. Approve it is basically, for example, with code review. So you can approve a pull request, and you can have, for example, a policy that it has to be 2 approvers for every pull request in the company. So for every approve, there will be another approve, another check, and who approved this pull request. So the basic of it is to blame someone else. So let's merge it. So we're going to merge. So you can change the merge message. And Bitbucket will not merge anything as fast forward. They will force a three-way merge. The reason is because they want to have in the history there was a merge in the system. Because a pull request will just squeeze the commits and just push it into one single branch, and you don't see like who pushed it in and etc. So Bitbucket forces three-way merge. So you can have an option close source branch, and let's not close it. Delete the pull request branch. So once it's merged,
If it's in the same repository.
yeah.
It deletes it over here, not in
So first of all, merge pull request from other repository. You have to be in the master repository in order to have permission to merge it, and then you can delete the other person's branch. The other person will get notified that his changes was eventually merged in, but it's a different repository. So let's merge it. So it's merged. There's even a label merged. By branches, you will see active branches. There's no active branches because all of the changes in every branch is in the master branch. Merge branches, you will see header. And the way Bitbucket knows that is the checks for all the commits so it checks for only lists out only branches that has different commit hashes than the master branch. So
If you had a branch still exists though. As
what?
long as you have the leader, it still exists.
Yeah, but active branches means that you have branches that has different history than your master branch. And merge branches is your old branches, but so as I told before, branches is basically a pointer. So it just points to existing objects. There's nothing to it. So everything is merged into. Let's get to the next workflow. Okay. So feature branches we talked about. Okay, online and Git. So GitHub has unlimited users. One of the good things about GitHub, and unlimited public repos, but you have to pay for each private repository.
Each?
Yeah, it's a plan. I think.
Packages of 5.
Yeah, but it goes per repository. They will charge you based on repositories. I don't think it's a wise decision for them. I don't know.
What do you get for $10 a month?
Like a certain five yeah.
5 repos.
Okay.
Bitbucket charges per user.
Yeah, but you can even have give permissions for other users from different accounts, and without even paying for them.
Where in Bitbucket?
Yeah. So I think Bitbucket is if someone uses just for their own code, Bitbucket is the way to go.
I'm not so sure. Not so sure. If you have more than 5 people on the
Yeah,
project, then you're running into issues.
Oh yeah, okay. Okay, I never had such a.
If you have a team of less than 5 people, you're right.
Mm-hmm. Okay.
If you have more than 5 people,
Also, Bitbucket. Okay.
you can have as many FFH, but you won't know who did what, because everything will go on the name of that FFH. Who did that change? Is basically based on, no.
Okay, so the Bitbucket is unlimited private repositories, pay per additional users. So the way they make the money is about users. Also, Bitbucket is very good about integration with Atlassian tools. So if you use Jira or Bamboo or the other types of services they have.
Explain what Jira is.
So Jira is a ticketing system with project management. It's very good for code. It's a little bit pricey.
They're very expensive.
Yeah.
They're very expensive on that part.
Yeah. So yeah, it's kind of like they want to bring in the community, and so they give out free stuff in order to bring it into their ecosystem.
Is that an integration with Confluence?
I think Confluence is Atlassian, no?
Yeah, it is.
So probably yes. Yeah. So everything with Atlassian works together. Everything is like one big thing.
HipChat.
Yeah. HipChat. Yeah. Whatever. GitLab. So GitLab is a very interesting project. GitLab is they created kind of like a clone of GitHub, and it's open source. So you can have your own GitHub hosted on your own servers, and it's completely free. You have to host. They have a hosted version for some amount, but you can host it itself. It's based on Ruby on Rails, and I set it up once. It's very cool. It has a lot of features that other GitHub and Bitbucket doesn't have. For example, rebasing. We didn't even talk about it, but there's other.
From the GUI?
So you can rebase your feature branches into the master branch. Yeah. So we can at the end of the talk. I didn't know how the people over here are in Git. So GitLab, if you want to have full power, GitLab is the way to go. What?
You have a website front end for the
Everything. So it's like GitHub on your own system. They have everything. It's amazing. So we are actually done with the slides. We can actually go deeper into other stuff on the command line.
Can you rename branches or?
Yes, you can rename branches. Some.
maybe rename the folder.
The way you rename a branch is very simple. You branch out from that branch.
So you don't rename it, you just delete the old branch and make a new branch.
It's the same, yeah.
Just a command. You can rename it.
Yeah, I think it's the same thing.
The name of the file, if it's actually the branch name.
So let's see. And let's say which topic, we can go in a little bit deeper. Let's say maybe rebase. I don't have slides. I think the rebasing has to be a little bit explained in slides. Let's see. Let's think of something. Git status, git rebase. Git. I think it's basically over. Let's see. Any questions? Bench. So okay, the thing with rebase, if you guys are familiar with rebase, rebase is very scary to do because rebase means you overwrite history, and if you are the only one having this branch, so no, you delete your old commits and you're editing the commit, so the hashes changes. The basic. Okay, yeah. Okay, so what exactly the question was?
Between rebase and merge, and when you use which one?
Okay. Rebase means you modify history. So you're asking about the differences between git merge and git rebase. So the difference is merge means taking certain things from other branches and putting in. You have a history in one branch, you have history in other branch, and you're taking history from one branch and you're putting it to the other branch. And could be conflicts.
You're losing the history.
You're not losing history. You just
the current branch is creating one commit, right? So you can have 10 commits in branch A, 10 in branch B, right?
it's not. It's not going to be 10 commits. You'll get 20. So you will have every commit. Yeah, it will have two parents pointing to the trees of the commits. If fast forward is possible, it will just push the 10 commits on top of the existing commits in master. So
It doesn't push, it already is. It's just
yeah,
pointer.
yeah. It creates pointers, and if there is a conflict, there will be a special commit where the conflict changes.
It doesn't bring in all the commits from the branch that I'm committing, that I'm merging from.
So let's say you have a master branch,
Right.
and you made some commits, and at some point you branch out to a new branch, and you make a lot of commits to the new
The
branch.
branch has 10 commits.
Yes, and
Master has all the 10 commits.
okay. So if master has
Now I'm merging
okay.
one branch into master. How many commits is master going to have?
Okay, so and when you will go into after the merge is completed, you type in git log, you will see actually 20 commits.
It's not like that.
Yeah, but let's show you what. Okay, so this is a confusing part. Yeah, this is a confusing part. So in Git, when you type in git log, everything will be sorted by timing, and this is going to be very confusing because you don't want to see even if the timing was right, a change from this branch and then a change from this branch. So there is sorting options that will sort based on branches. So it will show, for example, all the 10 commits from one branch and then start all the 10 commits of the other branch. But actually how Git resolves the merge conflict is it's not possible to squeeze in the 10 commits together. So the way they do it is they create one commit on the top with two parents pointing to the two trees of commits. So pointing to 10 commits of master, pointing to 10 commits of the other branch. And then if there is conflict, the conflict changes will be applied to this merge commit. Yeah. So yeah. But the merge commit itself will be saved only on the master branch because you merge into master. So if you go back to the other branch, there is no merge commit.
Does that mean the merge no commits, which no branches?
So
So if you then merge the master back into that branch, you get this single commit, copy it over.
yeah, so if you go then and pull in everything from master, you will get the merge commit.
But then you do
Both.
fast forward for
Yeah.
one commit.
Depends if you haven't made any commits in the meantime.
I didn't know that there's sorting because we use Eclipse. And
Okay.
Eclipse uses, I think, some kind of sorting.
Okay, this is very okay.
When I use the log, it's not always the same.
Okay.
So it's very confusing.
He's right, actually, same issues when you have two commits, when two people have conflicting commits and they just merge and
So there's a merge commit. The merge commit is where the differences get solved.
It's not a sure.
Yeah.
but this way you cannot sort on branches because it can sort on
So in certain types of GUIs, you can see like two rows of the commits. So it's very it's better to see how things work. You can see like in a roadway, you see like two roads and then one merges into the yeah. And it's very. You can even see it in GitLog. There is a graph option. GitLog. I don't think pretty. There's another one. Graph.
Graph, there's graph.
Okay. Yeah, graph over here. Yeah, you can see it. So you can see two branches on the bottom over here.
It's very confusing sometimes.
Yeah, so rebasing can solve a little bit of this. So if you have, for example, feature branches. So if you, for example, you have feature branches and your feature branch, let's say you started with a feature branch called header. You started working. In the meantime, in middle of development, the header, someone started footer, and actually the footer guys pushed in footer before you pushed in the header. So what happens is that you will see like 3 lines getting into master, and it gets a little bit confusing. So the way rebase will work is you will rebase on top of master. So what rebase does is it rebases your base from where you come from. So it will try to make your commits look like you just pulled out from master and you made the changes on top of master, and you can actually make a fast forward. So everything works very linear because there was no commits in the meantime. You just right now pulled out from the existing code from master, made your new changes, then back into, so everything is very linear.
So you're going to have the same number of commits but with different.
Yeah, so you will see like master, head, footer, then header, then whatever. You don't even see.
The messages.
So the messages, you can modify messages in the rebase, in the interactive mode. But rebase basically is just you're rebasing from where you come from. So
like replaying.
yeah, so they will try. Yeah, so they will try to push all the changes, existing changes into master into your current branch, and then they will try to push your changes on top of the current code. There can be some conflicts, but
If there's a conflict, then you'll have for every commit.
yeah, rebase can be very complicated. The workflow has to be very good.
Every commit.
I don't.
Look it up. R-E-R-E-R-E.
So I don't think rebase is a good thing because especially if you have remote branches and other users are using your branches, if you make a rebase, you change history. So Git will be messed up and you will be. So the commit hashes will be changed. Commit hashes will be changed because the contents is actually different.
Why is the content different?
Because first of all, it has a bit different parent. So the parent is a part of the commit, the contents of the commit, and the commit object, the hash will be generated differently. Also, if there's a command git demand. Git demand is changing messages. So if you're not happy with a message, you can use git.
You can add changes.
Changes too? Okay. So git demand is for making changes to commits, but the hash will be changed because the hash is based on all the contents that's a part of the commit. So the message.
If you're actually doing any changes to commit git command, changing files, you have already pushed all the commits.
Yeah, so you have to make a force push. There is a force push.
Git reset, git commit.
Oh, git soft reset.
Git reset head.
Okay.
One, hash.
Okay.
I would tell us to push. But then
So I don't think Git rebase is a good thing. The only place where when you really know what you're doing and there isn't too much remote branches involved, because it can be hella.
Like 2 or 3 users, and we all knew always what was going on.
Okay.
It was just neat.
Oh yeah. Then there's another thing in Git workflow. I didn't even talk about Git revert. So Git workflow works is there's no going back actually. You can roll back, but the way the Git community uses Git is not to roll back. So if you have, for example, a bad thing in your system, you just commit a new patch to the existing system, and everything goes fast forward. There's no going back. And Git revert is basically the Git revert does is it's not resetting your okay. First of all, Git revert. So Git revert will not reset your file system to a certain commit. So when you go and you put in Git revert a certain commit number, what Git will do is find the differences between this commit and this commit, and do the opposite of the difference. So, for example, all of the changes added will be removed. All the changes removed will be added. So they will just mirror the whole thing in the opposite way. And this is a Git revert, but it will be a new commit. So it will be actually a part of the history. So the Git revert will be a part of the new history.
I can revert in a branch to a commit that's 5 below.
Yeah. So you can revert any hash. Yeah, so there will be no, so no deleting. So Git revert works is it will create a patch on top of whatever's.
Wait, so then there can be conflicts with the latest.
So it's not going to be any conflicts because the way it's going to work is yeah. I have to commit. Okay, let's create some files. Okay, so okay. Yet. Okay. Okay. So we're going to create, let's say, hello world, and save it as test.txt, and save it in. Okay, over here. Okay, so git commit. Okay, so the first commit is basically hello world. Now let's create another commit. We're going to change the file, and we're going to add a new line. Okay, another commit. You can look git diff, and it's a command to look up differences, and you can type in git head and one before head, and it will tell you that hello world and test. Okay, this is also to do with the new line. I forgot the new line, so the new line was added to the first line.
Use git show.
Git show, you git show on commit, it will show you the diff.
Git show shows you the difference between the commit and the git diff shows you the difference between the current head and the commit.
Okay, I need the diff to go to the back behind. What? What?
Git diff is going to be the difference between your local.
So git diff is all about in your current branch. So you can point to whatever, to any hash number, it will show you the difference. So I'm going to create another line. So let's say, okay. Commit, okay. Git diff. Okay, test 1, 2, 3, 4. Okay. Okay, now I'm going to revert everything to be as the first commit. So only hello world should be visible on the file. So I'm going to first git log and see. Okay, this is the first commit. Okay, I want to be as the first one, so I'm going to revert the second one. So git revert.
You revert to the second one.
What?
That's the what's the issue? He's reverting the second one.
Yeah, so I don't want the second one, so I'm reverting it. For some reason, okay. There is conflicts, okay. Yeah, so
The third one has things that the first one.
yeah. So I have to resolve the conflict. So probably the conflict is I need just the world.
For the latest one, no?
And save it. Oops. Second. So over here, let's go back to git status. Okay, both modify. Okay, so when there is a conflict, Git will automatically add it to staging, and you will have to commit it. So git add, git commit. So git log. So let's make git git div head 1. You can see it removed test 1, 2, 3, and 4, but it's a new commit, so nothing was lost. It just turned around. What was added was removed, what was removed was added, and that's it. The problem with revert is, so at some point I had in certain projects that you actually want what you reverted, so you have to revert your revert. Yeah.
Like you unpublish the package on NPM.
Yeah. So you have to undo the undo. Yeah. It's not resetting. It's at some later on in the project you want to have the certain changes. Everything was changed, so you can revert your revert. So it will automatically. Yeah. So this is it's a very common thing. Search it up on Git, and this is one of the most common issues asked about Git. Is the revert. Yeah, I had a question about why I need to specify Git origin when I push code with the exact same branch name. So Git in Git 2.0 has a default that if you are in a current branch, they will try to match your current branch with the origin branch. So if you put in git push and you are in a master branch, it will try automatically to push to the master branch in the remote. But Git has mappings in the git config file. There's a git config file where you can put in mappings to certain branches. And I had a developer that used Microsoft Visual Studio. Microsoft Visual Studio has check out a branch as, and you can specify if you want to check out a branch from remote and check it out as a local branch, even a different name. He didn't know exactly what it is, so he checked it out as master. Probably that's what it is. And he made a lot of changes, and then he just typed in git push, and git push tried to follow the mappings, and he pushed it, the experimental code to master. And then there was a horrible time just to clean up everything from production. So the best thing.
Don't use Visual Studio.
So this is not just in an editor, but then if you just use git push, assuming that everything will be good, I don't think it's a good idea. Also, there's restrictions. You can restrict your repositories on certain branches, and I highly encourage you to do that, is to restrict pushes to master, and only one developer or build system to do it. What?
That's what forks are made for.
Fork is mainly for other projects that you don't know the project. But restrict to certain branches.
Git administrator, Robert Strauss. He's like a crazy genius. So he has like tons of restrictions. Exactly how it's supposed to be called and what you can push and what you can't.
Oh, okay.
It checks for certain things in the files, for spaces and all kinds of crazy things.
Okay, so yeah, there's a problem with new lines in Windows. If you use a Windows system, Windows uses different new lines than Linux.
When you install Git on Windows,
Yeah, it will ask you. Yeah,
that you should always
CLF, whatever.
with Linux line.
Yeah, so if not, it's going to be messed up, and there's going to be a lot of differences because everything is going to be changed because of a simple new line.
Moral of the story: don't use Windows.
Oh, okay. Yeah. So yeah, Git was first created for the Linux systems, but so there is problems with Windows of line endings. So you have to decide at the start of the project on which one to choose and stick with it at the end of the project, because there's going to be.
Set your text editor to only use Linux. Line.
Yeah, but the problem is with Visual Studio is if the text Linux new lines, it will ask you, do you want to convert it? And as every pop-up, you press yes instead of no. That's just the common way of doing things. So.
No, we're not using Visual Studio.
Oh, okay.
You made a comment before when you started about Git being a repository for documents, not for pictures, something like that.
Okay, yeah. So.
My question is, I understood that Git can hold any files.
Yeah, it could, but to see differences between files, it's not made for them, because the way they look at differences is with the new lines. Images is just a image map of bits. There's no new lines.
What happens if I make a Git repository of 100 images that I have? What's gonna
So
happen?
I had
So that files and I make a new commit. What's going to happen?
you can add images. I have a lot of projects that has images.
I'm going to see the differences in the images.
So it's not made for them. So the problem with that is, for example, if you have a high-res image, and the high-res image takes about, let's say, 20 megabytes, and you make one small change, you will get another 20 megabytes, and your repository will increase in size dramatically in just a matter of a few days. I had a project that had 1.5 gigabytes of storage, and Bitbucket warned them that they will close the repository. So I had to clean up the whole repository, remove all the history from images and PDFs and zip files and etc.
So it works for anything, but
yeah.
The diffs, the compressions.
Yeah, it's made for text files where you can see changes.
Because I was reading recently a very good idea to use Git for backups.
Okay, yeah,
Every backup is a commit. You back up your whole file system and you put a commit, and it's not going to grow because it's only a pointer.
Yeah, if the new files will just be new files, yeah.
Yeah, so if there's, let's say there's two new
Yeah.
files, it's just...
But if there is modifications to files, then it gets tricky, yeah. So there is a technology.
We have now B&H.
Yeah, there is a technology. I mean, GitHub has it. I think Bitbucket started using it, called Git LFS. So Git LFS is that instead of pushing the whole object of the file of the image, instead you save it somewhere else, and the only thing in the image file is a URL to the location where the file is stored.
So the repository stays.
Yeah, so it's just a link to and Git LFS works natively with GitHub. So when you check out your code and you see the code in the source in GitHub, it works as you committed the code. And actually in your workflow, everything stays the same. You just install Git LFS in your machine, and they will do everything.
Well, what are you trying to back up?
So this is about images. Now this is all about images of very large files.
In general, backups is an issue with backups. Because if you back everything every day, it's a lot of data.
Yeah.
If not, you risk losing a file.
What are you running? Is that
It's a general question of backups. Does not do it.
VM does snapshots.
Snapshots, yeah. Snapshots are basically a div, yeah. Yeah.
No, they store the deltas.
Yeah, the divs, the deltas, yeah.
The dollars, the grand dollars.
Okay, the thing I didn't talk about is tags. So Git has a thing called tags. It looks like a little bit like branches, but it's different. So tags is you can give a name for any hash with a tag. Tags is very used for versioning, also for build systems. So you can tag certain commits. But the tag means that everything behind the tag is a part of the tag, and everything above the tag is not a part of the tag. Branches is the opposite way. So every commit on top of a branch belongs to the branch, and tags is the opposite. All of the commits from yesterday till today till this tag is a part of this tag.
Like the versioning.
Yeah, so versioning. So there's a very common thing, versioning. I set up for a company a build system. So the build system automatically deploys for the production, and once it finishes, it tags the latest commit as production. So you can go into Bitbucket and see where productions are at. So.
I had a question about the way Git handles the conflicts. I don't know if you can pull easily up the slide, the example that you had.
Okay.
So the example was that if, let's say, the master branch, you had a file that was like two, line one was 40, line 2.
Okay, let me get to the slide. So. Okay.
Then when you branched out, the branch bar,
Okay.
you changed line 1 to test.
So I changed line 1 to test. Yeah, I replaced
The
foo.
master branch.
Yes.
Let's do and you added a line in
And the other branch.
the
Yes.
development, let's call it the development branch, right?
Yes.
But then let's say in the master branch, on the new commit, you also added line 3. But then you found some bugs and you removed them.
Okay. So the Kabir conflicts. Okay. So
Only the initial branching, or does it look also later on seeing, oh, you added over here as well, then you removed it
So-
probably because of some bugs and don't add it.
so the way it works is if you so you're asking if I added lines later on if Git will
So
recognize
master
it.
branch, you later on added line 2, but then removed it because of some bugs.
Okay.
And now you're merging the development branch into the master branch.
Correct. Okay.
Will it be aware that line 3 has been added and removed and not added again, or will it just add it in?
So Git. So you're asking if Git will recognize that the new lines will be removed and then added other stuff. So Git doesn't care about that much because Git only cares about from where this branch and this branch had in common. And the only differences they care about is from the latest time you were both on the same page, what changes was made to this branch and this branch. So this is the common ancestor part of Git. So where both branches had the same file system.
It's going to show a conflict, right?
What?
It's going to show a conflict.
Yeah, so if you made a change that, let's say you made a change, you added a line 3 and the master over here, and you added something else, and you try to merge it, there will be a conflict, and you will have to resolve it manually.
I'm saying you removed
He
line
has a point. He has a point that there is a bug actually in this algorithm. That if you add in the master branch, and then you decide to remove it.
I'm saying you removed line 2.
They did the same thing in the second branch, but didn't remove it, and it's still in the second branch. Then it will
No, so they
get inserted.
yeah, so they know that. No, it's not a bug because this developer has nothing in common with the other developer. Whatever this branch with this branch has nothing in common. So when you added stuff and removed that stuff, it has nothing to do with the other branch. You made it separately. If you're pulling in the same commit number and you have the removed and added changes, the common ancestor will be shifted upward because where both branches had in common.
You need to be aware of. You need to be aware that if you
Yeah, so if you had the same commit, means that you were on the same page with the other branch. So all we care about changes later on. But if you do it manually and you, for some point you remove the same lines, added the same lines, Git don't care because it's different branches. You don't know about them. You had different intentions. So Git test, Git reset. Git reset is basically removing from staging. So if you made like 5 changes, you want to split it up into commits, and you added everything, you can reset, you remove certain things from staging. Also, Git reset has a heart, and it removes all the history to a certain point, a certain commit. So if you want to saturate your whole file system to a certain commit, you can type in git reset --heart with the commit number. Just warning, it will erase all the history, so be careful. Git reset soft will not erase, but it will take the differences, create it as one big change, and add it to staging, and you can commit it. This is a common technique of doing squishing.
You can still revert the reset.
So resets is very hard to revert because you actually removed your history. You reset it. Yeah, so you reset everything.
Oh, it moved the history and then combines everything.
So reset hard is 2 things. There's reset hard. Hard means go to a certain commit, reset everything as that commit.
Okay.
So for example, as like git checkout, but reset everything. So you type in git log, you don't see any logs upward.
The log as well?
Yeah, so you don't see anything. So you remove the history. Git reset hard. So soft is a common technique of squishing commits. You can do it in git rebase interactive mode, but you can do it in git reset soft. So for example, you have 5 commits. You want to squeeze it in as one commit. So you type in git reset soft, and the first of the 5 commits, it will reset all the 5 commits as one big change and add it to staging, and then you can commit it as one commit.
What's the difference between soft and mix?
I think mixed is the default git reset.
How's it different than soft?
So soft actually removes, squeezes the commits as changes to a file, and it removes it from the commits.
And mix?
Mix removes it from the staging. Just removes the files from staging.
It's not a staging. I made 2 commits. Now I do git reset head tilde 2. I'm removing 2 commits. What's the difference between dash soft and dash mix?
So mixed is made for removing from staging. I think this is the default. The default from git reset. If you type in just git reset, it's mixed.
Git reset is only made when you're not doing any commit resets.
So reset is basically from removing from staging. Yeah. Also, git ignore file is basically ignoring certain things for git. So if you have local changes you don't want to push to a repository, put it into the git ignore file. There's some formatting how git ignore works, and put it into git ignore. You have to make sure that the ignored files are removed from staging, and because once it's committed ignored files, git ignore will not work. So you have to first remove it. Git reset. You can restrict people from pushing to branches, I guess. But so git fundamentally is that every git is local, so there's no restrictions what you can do. You can restrict from the remote. Every git is local, and your machine, you do whatever you want. You can create branches with all types of names. You can have the master has nothing to do. No, you have to push it in order to any change. What?
It pushes only every new commit.
So if you want to reset, let's say a remote branch, let's say master, and you're a master, you make a git reset to a certain commit. So history is changed. It removed certain commits.
That's still on the local.
Still on the local machine, but if you want to force the remote to have it, you type in git push origin master, but with a dash f for force to override remote. I highly discourage to do anything with force. It changes history, sure. So anything with force will will force anything. So sometimes when you do some reverting and rebasing, not reverting, rebasing and anything modifying history, the remote will not let you push anything, because
The only time to do a reset is when you're ashamed of what you've.
so git saves actually every step, every type of command is saved in git. It's called reflog. And you can look it up every time.
You can actually do a get history, so is it lost in the reflog, or it still stays in the reflog?
So yeah, the object stays. So the object stays. Yeah,
have the parent of the
exactly. Yeah, so it's just unattached from the pointers, but the object stays for caching. So git reflog, and you can see this commits. There's even git reflog. Nope. Also, there's a lot of formatting for git log. There's a git log pretty one line, shows you very nicely. There's pretty format. It's raw. Okay, so raw is actually how the actual file looks like. So you can see is the author, committer, and then the tree hash. So this points to a tree object. The tree object is constructed with all the files in the tree. So it starts a tree graph of how your files look like. It starts with a pointer to a tree file. The tree file will show you if it's a file or it is a no folder, and then if it's a folder pointing to a different file, and then the other file will show you all the files inside. So it's like a whole tree constructed. So if you make any changes of moving files, then the tree object will be modified, but not the content. You can have multiple remotes. You can have people are doing multiple remotes for a lot of things, like people are doing a lot of A lot of things have multiple remotes because of backups. So you can have all limited amount of remotes. Any project, you have to give it a name.
People do deployments by
Have-
games, so they push the staging and they push the...
Yeah, so you can have You can also have remotes as a remote machine. You can even have remote as a separate folder in the same machine too.
Local directory.
Yeah, so you can have it as a local directory. When you clone a repository, you can clone the repository with all the history. Then there's also an option bar. Bar means that it will just bare, so it will only clone the contents from the files and not the history. So if you don't care about the history, just a copy of it, use the bare parameter.
What's the difference between fork and clone?
So fork is a GitHub thing. That has nothing to do with Git actually. It's a fancy clone.
Clone or a fork?
So clone will download it as a file in your browser. It will download to your machine. Fork will take in your username. So what else? There's also the same as I told with Bitbucket. That Bitbucket shares objects. You can actually do it with yourself. You can add, you can specify for Git where the objects get stored. You can specify, for example, I had a client that had a build system and there was a lot of builds on the same machine. So instead of having to pull every changes for every build, I specified one folder for all the objects, and all of the folders share the same objects from one location. So the download time was very fast because they share the objects from the same repositories.
But it's stored in a different place, no?
No, so you can specify for Git that all of the objects is going to be stored at some central location. It's very good if you have a lot of build systems. What? The same? Yeah, probably.
Why is the download time faster?
Because you don't have to download every object for every time you clone the repository.
You already have it.
Yeah.
Okay.
So if you have like a build system that has a command that clones the repository for every build to be
Can you see the difference? I mean,
everything works the same. It just Git takes it from one central.
download time because of it? You actually-
Sure. It will not download anything. It sits on the same machine.
Like if you're using jQuery in Project A and jQuery
Yeah.
Project B, it only requires jQuery once, and then when it downloads, it's there.
A common scenario where people are using it is build systems. So if, for example, you have one big build machine that builds the project multiple times, it's the same project, the same code base, but rebuilds it for every time. So why is the need to pull from a remote server every time for every build? Just have the objects in one central location and reuse the objects for every time.
And then of course if you specify different versions of download again.
So as long the hashes are the same, you're guaranteed to have the same content. You don't have to worry about it.
Once you're saving on bandwidth and storage.
We did the difference between downloading it from a remote server.
Exactly.
outside of your network.
Yeah. So basically, I think I can wrap up. I think that's it. Thanks so much.
Thank you.